Hey, let's solve this last problem from our assignment using Desmos. A ball bounces and then travels in a parabolic arc through the air until it hits the floor again. At the highest point, the ball is 4.5 feet off the floor. The 2 points where it hits the floor are 3 feet apart. So draw the graph and write an equation to represent that movement, and then another one for a ball that bounces twice as high in the same spots. I'm going to use Desmos and make a little table here. I'm going to put my values at x equals 0, y equals 0, and 3 feet over, x equals 3, y equals 0. So that's going to place 2 points. That's where I want the ball to strike the floor. All right. And then after that, I need a parabolic arc, right? So halfway between them is where the parabolas are symmetrical. Halfway between them is at 1.5. And I want the y value at that point to be 4.5. Okay, so I need a parabola that goes through those 3 points. All right, so I could start with a vertex form and try to make it fit. That'll work. Or I can start with the factored form using those two roots and try to hit this vertex. So let's try both of those. Vertex form is x minus 0, or x, and then x minus 3. Make it negative to flip it over. And I'm not quite there yet. I'm going to try doubling that, and that's what hits that spot. Maybe you would have some other decimal to make it fit nicely with other values. It happens to work out nicely for this one. Okay, so that's one way to get there. Let's make that one quiet here. Let's do the vertex form. Again, we'll make it negative. The vertex is at x minus, let's see, halfway between 0 and 3 is 1.5. So x minus 1.5, oops, 1.5. Or you could write 3 halves. That's squared. And then we need to add 4.5 to it. Now look, it misses because it's too wide. So we start increasing the a value to make it steeper by making it 2. That works. And if I turn on the other graph here, you can see that color. And now that we have either one of these forms, if I want another graph that's going to hit the same point, 1.5, but at the height 9, way up there, all you do to get that, I'll just change this one, is change your 2 to a 4. Oh no, sorry, not the 2 to a 4. Yes, change the 2 to a 4. Sorry, did that wrong. Change the 2 to a 4, but then you also have to change the height here. There you go. Doubling it so that it happens twice as fast, and it hits that point up there. On this equation, if I do this, change the 2 to a 4 here, we get there automatically because the roots stayed the same. I'll make this one a 2 again and a 4.5 to show you. We only have to change the compression factor on the factored form to get what we want. On the vertex form, we need to change the compression factor and also change the y value of the vertex. So a couple of ways to fit quadratic curves to values that you have from an experiment. Thanks.